Hi there, thanks for that. It was great. Yeah, I just want to say hi. I'm Peter Cooper, and I'm one of the two co-chairs, not just of this online conference, but also of the kind of the real-life O'Reilly Fluent conference, which we'll briefly mention in a minute. But yeah, as I said, I'm one of the chairs of that, along with my, I guess, now friend, Simon St. Laurent, and he'll be introducing himself in just a second. But I guess just to kind of tie things together here, you may know me from being the editor, or kind of actual ex-editor. I've handed it over, the reins over to someone else recently, but as the editor of JavaScript Weekly, which is one of the sort of the more popular newsletters in the JavaScript space, and I do a bunch of other stuff as well. So if you come from the Ruby world, you may have heard of some of my exploits there as well. So yeah, so I'm just involved with this conference generally. I co-chaired it in the first year as well, had a really great time. So they managed to get me for year two. And Simon has come in new to it since our other co-chair has left. So I will now hand over to Simon to give his introduction. Thanks.
Great. This is Simon St. Laurent. I'm a senior editor at O'Reilly Media, Inc. I've been working on the web for about the last 20 years, something like that. I've been at various times a developer, a documentation person, a coder, pretty much everything except a designer proper, because you don't want to see the things I design, really. But I'll hand it back to Peter to talk about what this online conference is about.
Oh, I do want to see what you've designed now. That sounds like fun. Yeah, so I just want to say why we're here today. We're not just here to give you like a really great free online JavaScript conference experience all online, but it's kind of like a preview of our real-life event as well. So last year we ran an in-person JavaScript Summit. We called it prior to the conference, and that was in downtown San Francisco at the same place, but it was for about 50 or so JavaScript developers. Worked really well, but for this year we thought we'd make it a little bit more open and transparent and allow sort of more people in. So there'd just be more value overall. So wherever you are on the globe, and whether you can actually come to the Fluent event or not, you can join in. So thank you very much for turning up. So we're going to hear 4 different talks from 5 speakers, because I believe one talk has 2 speakers. So each is going to cover a slightly different angle of what we're trying to do with the main O'Reilly Fluent conference. So it really is a true kind of cross-section preview. And first up, we're going to have a pure JavaScript talk. So that covers that angle. But then second, we do cover HTML5 as well, and browser technologies generally. So the second talk digs into some of that, and how to use HTML5 and JavaScript to interact with hardware, which sounds kind of fun. I'm looking forward to that one myself. And then the third talk is going to be about the kind of the server side thing, because obviously, as you know, JavaScript can be used on the server side with Node.js in particular. Last but not least, there's going to be a talk about Angularjs, and that is essentially the talk about a prominent framework in our space, of which there are many, but Angular was lucky enough to make it into this program, and we do particularly like Angular as well. So we really hope you enjoy the event, but I'm just going to hand it back over to Simon now briefly, because he's going to explain what the actual real-life Fluent event is about, and what will actually be going on there.
Yeah, so Fluent includes a lot of great things we can't really demonstrate online. I'm really happy with this, but 3 days in a single space makes a big difference. I'm especially excited about the workshops. We have 3-hour intensive training sessions on a wide variety of web-related topics. We'll have Ilya Grigoric showing us how to build faster websites, and we've got workshops on Node, Jquery, mobile web development, Bootstrap, and app packaging too. And then during most of the main conference time, we'll have 4 sessions at a time you can choose from, covering all kinds of front-end, JavaScript, and Node topics. We've got a great lineup of speakers, just a few of them: Steve Sanderson, Estelle Weil, Chris Wilson, Brian Rinaldi, and Rachel Neighbors. And they'll be exploring the rapidly evolving worlds of JavaScript, HTML5, and all these things in the browser universe. I'm not always a fan of keynotes, but the Fluent lineup has me happy that I'll actually have to be there for all of them. We open with Brendan Eich. We have Irene Ross, Nicholas Sakis, Leah Veru. We'll have Bill Scott releasing the Kraken. I'm curious what that's about, but we'll see what happens. And one last point, there are still opportunities for you to get involved in the conference if you're planning to be there. We'll be having Ignite talks on the Tuesday night, and we'll be having a call for those talks. And there's a startup showcase which has a call that's open right now. And so if you have a startup you'd like to get out in front of the world, definitely visit the Fluent site. It's fluentconf.com. You can follow @FluentConf on Twitter. And we have a lot more information on all of those things there. So anything else left to say before we begin?
I guess I just want to repeat actually what Yasmin said earlier about, it'd be great if people want to tweet about this, if they learn anything interesting, that type of thing. And as was mentioned earlier, use the FluentConf hashtag. But you can also tweet me directly at Peterc, that's P-E-T-E-R-C. I know that Simon won't mind tweets as well. He's at Simon STL, I believe. And there is also a conference account at @FluentConf. If you have questions about the conference, we have people at O'Reilly actually monitoring that and can answer questions if you have any questions about tickets and all that type of thing. So is there anything else from you, Simon, or are we ready to go?
I think we're ready to go.
Oh, great. So yeah, it's a great pleasure to introduce our first speaker. It's Martha Girdler of Etsy, and she's going to talk about this in JavaScript, how it really works. And if you just look around the internet for a basic description of what this is, you'll come across an article on a site called quirksnode.org. And I just like the way they start their article off. It says that one of the most powerful JavaScript keywords is this. Unfortunately, it's hard to use if you don't know exactly how it works. And I guess that's really the best way of leading into this. This is exactly what Martha's going to cover. So I'm very happy to hand over to her.
Well, thank you both so much for that introduction. Hi, everyone. My name is Martha, and I am a software engineer for Etsy. And today, I would like to talk to you all about how this keyword works in JavaScript. But before I actually dive into that, I need to give us a little bit of context, which, by the way, that's a slight pun because the value of this is completely dependent on context. But we will totally get back to that later. If you haven't already read JavaScript The Good Parts, I really very highly recommend it. Crockford reduces JavaScript into a reliable subset of the language, and I might have read it 4 or 5 times. But I feel like Crockford is really right in this little clip that I posted here. Understanding functions is paramount to understanding JavaScript. And to understand JavaScript functions, you actually need to understand how the JavaScript interpreter creates them. I think the slide's loading. Oh, there we go. So before I actually dive into the really technical aspects of this talk, I wanted to show you this picture. Because I use KitKat and Eula in a lot of my examples, and I just wanted you all to know who they are. The little gray cat is KitKat, the white cat is Eula, and yes, it stands for End User License Agreement, and the guy in the middle is my really cute husband. But anyways, moving forward. Okay, so one of the great things about JavaScript is that everything is an object, and this makes the language extremely flexible. One of the even cooler things about JavaScript is that all of the functions are actually first-class objects. This actually means that functions can be stored and referenced and invoked in a number of different ways. So here in the slide I've just showed you can store them in a variable, an object, an array. They can be passed as arguments, and they can be returned from other functions. But the JavaScript interpreter does some pretty weird things when it comes to creating function objects and scope chains. To understand JavaScript, you must understand how the JavaScript interpreter creates function objects. I never truly understood scoping or identifier resolution or this in JavaScript until I understood more about how the JavaScript interpreter works. And by the way, when I say identifier resolution here, I just mean if you try to access a value on an object and it isn't there, JavaScript will continue to look up all of the identifiers in the object scope chain, all the way up towards the window object. And it will either find it or it won't. But we'll talk more about that in upcoming slides. So here's a little bit of weirdness to consider. I'd like you all to pause for a second and think about what's happening here. The key takeaway in this example is that JavaScript's not throwing a reference error here, which a reference error is an error that gets thrown when a non-existent variable is referenced. It says the variable is undefined. And what's interesting about this is generally referred to as hoisting, and this happens because of the way variables are instantiated in the JavaScript interpreter. And we'll talk more about this later. I just kind of wanted to put this in the back of your mind. But this is also why, as a matter of good style, it's best to declare all of your variables at the top of your function body. And you'll see why soon. So Now let's get into a little bit more about how JavaScript interprets your code. All JavaScript code is executed through an execution context. Global code, meaning any global level functions, get executed in a global execution context. And each subsequent invocation of a function has its own execution context. You can think of an execution context as an abstract object with properties, but it's not public. It's more of an internal construct of the language. And because functions are first-class objects, they can be called in many different ways. The execution context is just the environment at runtime that the function is called in. An important thing to note about execution context is that if another function is called, or if the same function is called recursively, a new execution context is created, and the program enters the context for the duration of the function call. So basically what all of this means is that your JavaScript code that you're running forms a stack of execution contexts. That's why you may have heard of a stack before regarding JavaScript. The topmost context or execution context is the currently active one. So when a function is interpreted, an execution context, like I said, is created, but also a number of things happen in a defined order. This is basically what's happening behind the scenes. The first thing that happens is an activation object is created, and it's basically a specification construct. You can think of it as an object with properties, but it's not a normal object, and it doesn't have a prototype, and you can't directly reference it by its code. It's basically just there for the interpreter to use for its own purposes. So the second thing that happens is an arguments object is created, and the arguments object is an array-like object that stores the arguments given to that function in order. A reference to the arguments object is assigned to a property on the activation object, and that's really important to remember about the first step when the activation object is created. It basically just stores the state of this current function. So the third thing that happens is the execution context is assigned a scope. The scope for a function is a list or a chain of objects that it can access. And this will make more sense later, just kind of store that in the back of your mind. The fourth thing that happens is named properties are added to the activation object, even though at this point it's technically referred to as the variable object, for all of the parameters, function definitions, and local variables that are declared within this function. So basically it's just a name referencing the name, the identifier of all of these parameters, function definitions, and local variables are added internally to this activation object. And that's important, and we'll come back to that later. And so number 5, the final thing that happens is, finally to address the namesake of this talk, the value for this is assigned based on the current execution context. And we'll see more about what that actually means soon. So here's a big stumbling block for a lot of people starting in JavaScript when they're used to another language is despite JavaScript's C-like syntax, it does not have block-level scoping. JavaScript actually has function scoping, which is otherwise known as lexical scoping, because scope is defined in the activation object of each individual function. It is not defined in each block like an if block or for or what have you. So quick note about variable instantiation. The properties created, oops, sorry, I got a little lost. Oh yeah, the properties created on the variable object for local variable declarations are initially assigned as undefined. So that hoisting thing that we saw earlier, when the activation object is being created, the local variables are instantiated as properties of the activation object, but they are assigned undefined as default. So it's just pulling up the name so it can reference it at other points inside this function call. But the actual assignment of the value to that identifier does not happen until evaluation. And when I say evaluation, that's when you're actually assigning the value with the equal sign to the identifier. So maybe now that will shed a little light on what hoisting is all about. Because actually the name, the actual identifier of the variable is being hoisted into this activation object, but not the value. Okay. So now I would love to talk a little bit more about how the scope chain is defined within this execution context. So the scope chain contains one or more variable objects that define in-scope identifiers for the execution context when it was invoked, when the function was invoked. So this little diagram here illustrates a function inside another function, which sits in the global execution context. So when this inner function is created, it's created with a link to the variable object and its parent, and also its parent's parent. So when the JavaScript interpreter is trying to look for things in scope, it looks at all of these links of all these variable objects that are in scope for that particular function or object. And that's why inner functions have access to the variables and parameters and functions of their outer functions. So I've been talking a lot about identifiers, and an identifier is just the name of a property or function. Identifier resolution begins with the first object in the chain, like we just saw earlier. It checks to see if a property with that name that corresponds to that identifier on that function, and then if it doesn't, it'll look on its prototype. If it makes this there, it'll look on its prototype, or I guess it's prototype's prototype, all the way up until you exhaust the scope chain by reaching the global object. And if the scope chain is exhausted, that value will just resolve as undefined. And this little note on my slide is really important to understand. It says identifiers are resolved against the scope chain, not the value of this. This is resolved depending on how the function was called and not the scope. And that's because this is actually considered a keyword. It's not considered an identifier. Here we go to the, like I said, the namesake of this talk, this. So this holds a reference to the object that the function is being applied to. So for example, if you're invoking something in the global context, this applies to the global object, or if it's a method, if you're invoking a method on a particular object, this refers to the context it's invoked in, which would be its parent object. So this does not necessarily mean that this will equal the object where it is stored. That's really important to understand because the value of this is decided at runtime. So this definitely means that the value of this doesn't always equal the object where the function is stored. And we'll see more about that soon. So here's a little example. Demonstrating that the value of this is not always the context in which it was defined, but in which it's executed. When say hello runs in this slide, it executes as a member of the object EULA. So this .name, so the name property on that is referencing in this function will be used as is referencing the EULA object and not the KitKat object. Also, just another note about what's going on in this particular slide. We haven't modified KitKat's sayHello method at all. EULA.sayHello only has a reference to the function, and this is because JavaScript passes by reference and not by value. Okay, so I've done a lot of talking so far about execution context. You may be thinking, what is that? I'm just going to go over a couple of the more common execution contexts. The first one would be a function just invoked as a method on an object. So this is a particular execution context where the value of this references the object that it's stored in. A function can also be invoked as a constructor. Here, the new keyword is essential because it tells the interpreter that you're using this value Kindle, not as a function, but as a constructor instead. If you were to omit the new keyword, it would just simply execute this Kindle function, which returns nothing, and then the variable EULA and KitKat will have no value here. But when we instantiate objects with this new keyword, the value of this is set to the reference of the newly created object. So another way that functions can be executed is just as a regular old function. And one important thing to remember about JavaScript is the default scope is the global window object. So that's what we're all talking about, or that's what we mean when we're all talking about implied globals in JavaScript. All top-level functions and variables become methods and properties of the global object. And you might be asking yourself, why does this happen? But the window object goes through variable instantiation just like any other object. And when that process happens, these values are appended to the global object itself. So one thing that trips up a lot of developers with JavaScript are the concept of call and apply. Basically, call and apply are just methods that allow you to apply the method of one object in the context of another object. So you're basically just controlling the scope in which it's executed. So here, you're able to execute a function basically if it were the method in a different context. So here I'm calling the method, say, name in the context of EULA. So this.name will refer to this inside of the EULA object. And apply is identical to call, except apply requires an array as a second parameter, but you can look up the documentation for that if that's something you find yourself needing. Okay, so now I think we are able to talk about closures. And just as an aside, this picture is a really accurate representation of what I looked like in middle school, except I had headgear. So the concept of closures are often scary and confusing, but it definitely does not have to be. In plain English, a closure is created when a function remembers the variables in its scope when it was created. So a function creates a closure when it stores the variable object and keeps it and returns it. So that means that these values are kept alive and able to be used even after the parent function has executed. So effectively, you're just closing over these values, hence the name closure, and you can make them accessible. And just as a reminder, I wanted to throw this slide back in here just to show you how the variable objects are linked, because this is a powerful mental model when thinking about variable objects and scoping in prototype chains. So, okay, I know I've blown through this really quickly, but I also want to just show you, here's an example of a closure. Basically, the inner function has access to the variables of the outer function based on the scope chain and the variable objects during instantiation, and it's returning those values. And this means that it makes those values available outside of the boundaries of the outer function. So like I said, that was a whole lot of content, and I'm sure I spoke very quickly. I would love for you to interact with me on Twitter. I'm at Martha Kelly. I'm happy to answer questions or talk about things. And I hope you enjoyed this presentation, and I hope you learned something. Thank you.
Great. Well, I'm delighted to introduce our next speaker, Wes Boss. He's a designer, developer, and entrepreneur from Toronto. This talk really pushes the limits of what I ever thought I'd be doing with JavaScript. I remember when I was all excited about making messages appear at the bottom of the window. He's here to push those limits, take us out of the classic JavaScript sandbox. And as our mobile devices become more capable, and I guess as we become more comfortable with them, a whole lot of new opportunities open, and he has the keys.
Awesome. Well, thank you, and thanks everyone for coming out. So my talk is a little bit more interactive than some of the just regular PowerPoint presentations. So in order to get kind of the best experience, I recommend that everyone go on out and open up the slides rather than just viewing them in the screen share. So if you go on over to my Twitter, which is twitter.com/WesBoss, WESBOS, you'll find a link to them there. And if you click that, you'll be able to follow along. They work best in Chrome, but I haven't really tested them in too many other browsers, but I'll make sure they do. So without further ado, let's get rolling. My talk's about HTML5 hardware access with JavaScript. So my name is Wes Boss. I'm an independent UI designer and a web developer. I'm from Toronto, Canada. I design and build front-end applications for websites, so I primarily work with startups and agencies and like fully developed companies from around North America. I'm a huge JavaScript, CSS3, and HTML5 fan, so a lot of the stuff you'll see me tweeting about, a lot of stuff you'll see me posting on GitHub or my blog is kind of just looking at new stuff that comes into the browser and how can we use this not necessarily for something that we could put into play on like maybe a client site right away, but how can we use it now and look forward to the future. Whoops. I'm writing a book on Sublime Text right now, so if you are interested in learning on becoming a superpower user, I definitely recommend you check out my blog at wesboss.com, and that should be out in the next month or two. I'm a lead instructor at Latest Learning Code and HackerU, which are two local coding learning organizations here in the city. And then again, I'm on Twitter at wesboss. So let's get rolling. HTML5 hardware access, but with JavaScript. This talk is about accessing hardware inside of mobile browsers. So device APIs that either we have today or ones that are coming in the near future. So we might not necessarily be able to use them in application just yet, but hopefully in the next year or two we'll be able to put them in our apps. So I'm not talking about PhoneGap today. I'm not talking about RubyMotion, not talking about web views. I'm purely just talking about things that we can access in our mobile browsers. So I'm not here to fight against what's better, what's not better about native devs. HTML5 isn't the solution to everything. There's many stories to support argument on both sides versus native versus JavaScript. So I come in peace if any of you guys are native developers. So hardware access. Today we look at 4 different types of hardware access for the mobile web, and then hopefully I'll have a little bit of time at the end for a couple questions. First is file system. Second one is accelerometer. Third is compass. And fourth is camera and audio, which is WebRTC. So the first one is speedometer. For those who haven't done it before, if you look in your JavaScript console, there's something called geolocation. And basically what that does, you've probably heard of it, is it gives you your latitude and longitude associated with where the person is at. When you call geolocation, .get current position, it'll say, hey, do you want this website to be the current location? And it'll tell you where it are. One really cool thing about that, though, is that you also get something returned called speed, which many people don't know about it. So when you call get geolocation, you get your latitude, you get your longitude, you get a few other things, but you also get one speed that's delivered in meters per second. Cool. So I thought, well, what can I do with that? Maybe I can make a pure HTML5 and CSS3 speedometer. So I set out to do that. My goal was to just have everything run right inside the mobile browser on your phone and not to use any images. So I started off with just a little bit of basic HTML here. I'll run through it with you quickly. Just have a div. I have a span with for the needle. This is what it looks like at the end of the day. So you can see that I have a needle, we have some ticks, and then we have just a background on it. The ticks that go around the outside were just an unordered list, and then I had a speed wrapper to basically dump the kilometers per hour, or if you are American, we could change it to miles per hour for you. So once we have some basic HTML, so that's just a couple lines there, I wanted to go ahead and use navigator.geolocation.watchPosition to actually get the data. So when you call it, you can get a callback here, and you pass the data. I'm using D. And then I have another function called sp.writeSpeed. And basically what that takes is it takes the latitude, it takes a lot. It throws all that out. It doesn't need it. It just needs that speed on the object that we get back. And then calculating the speed and visual displaying it was a breeze too. So back here is what I called is watch position. And basically, watch position will update itself every so often when it has some new data on how fast you're currently going. So right here, I passed it that data object. Remember, we just saw it. And to figure out the current speed, we just did a little bit here. If you're a weirdo from the States, then you use miles per hour. We convert it here. And then finally, what I did here is I needed to figure out at what angle I needed to move the needle. So here, if you're driving, you're looking at your needle. The faster you go, the bigger the degree of your needle will go. I'm trying to explain it with my hands here, but obviously you can't see me. So maybe do it with your hands yourself. So I just use a little jQuery here to needle a certain number of degrees, and we're off to the races. So that's what it looked like at the end of the day. I loaded it up on my phone, and I went outside, and I started running down the street to get myself 9 kilometers per hour, and I saw the needle go up. So I was pretty happy with that. But my next question was, does it work while circling on an airplane? So I was working on this project when I was visiting my wife's family for Christmas one year, and on the way back from Christmas on the plane was just circling around as it didn't have a chance to land. And the beautiful thing about GPS on a phone is that it doesn't require a data connection to work. It just requires a GPS connection, right? So I popped on my phone and brought it up, and surprisingly enough to me, I didn't have a data connection, but since I used caching, I was able to access my web app, and I brought it up on my phone, and I got 339 kilometers an hour. So I never thought that I could get that fast ever, unless you were on some sort of train in Europe. But I got it up, and you could see it spun all the way around. I need to edit it for faster things like that. Looks like the needle broke. Someone just put in the chat. Yeah. So that was the compass. And let's talk a little bit about file input and file reader. So perhaps the biggest limitation of mobile websites in the past was not being able to access the user's file system, the camera roll if you're thinking of iOS, right from the browser. So what if we actually want to access those things? So here are a few examples. If we're on the mobile Facebook website and we want to upload a photo, or if we want to attach an image to a web form. So if you only have a tablet or a mobile phone and you're trying to fill out a form that requires you to attach images, you're kind of out of luck, or you are at least out of luck. Next one, doing photo editing right inside the browser. So you can do Instagram, Reddit, correction, you name it. And then the final one was upload videos or photos to a service without their app. So it makes sense to download someone's app if you're going to be using it quite often. But if you really just want to edit it just once, and you just want to use the app just once, it doesn't really make sense to have to download it and then delete it after you're done. So that's where file input comes. It's an old friend in the browser world, and it's been around in Android for some, but it's only recently been supported as of iOS 6. And there's no polyfills or shims for it to work in iOS 5 and below. So it's not like we could just do a graceful fallback for it. So until this great piece of HTML5, input type equals file comes around. Yay! Clicking that brings up the camera roll you've seen before. Takes a photo or video, or you can choose an existing. So, and then when you actually select one, it then gives you the data right inside the browser. But what can we actually do with that, you say? Well, let me tell you. Obviously, we can upload the file to a server, so that's probably the most basic one. You choose a file from the server, and you upload it, and then you go ahead with your life. But that's pretty boring. So it's 2013. We want to work with files right inside of the browser. So we want to have to rely on a server-side component when we don't necessarily have to. So next, so with File Reader, that's where we can actually start accessing files right inside of the browser and accessing them. Once selected, the browser has a blob or a raw binary data. So basically, when you select an image from your iPhone or Android, you get something called the blob, which is all the bits of that image, and it's accessible right inside the browser. This means we can upload images and manipulate them right inside the browser. So I like to make fun little demos out of new things like this. So I created a startup, which it's in early seed funding right now, but I hope to sell it to Facebook for a couple of billion in the near future. So it's called Crapstagram, and it's exactly like Instagram, but only with one crappy filter. So demo time. Usually I pop this open on a mobile phone at a conference, but since we're on the internet today, I have it open in my browser. If you want to try it out, it's available at wesboss.com/demos/crap. Then go ahead, choose a file. Got an image of a sandwich right here. And as soon as I upload that, you'll see I scroll down here. It takes that image of a sandwich and puts a marvelous kind of hipster sandwich effect on it for you. So what did I just do there? First, I created a web page with a file input, and I used Canvas. So if you're not familiar with Canvas, it's kind of like a pixel-based drawing and manipulating Microsoft Paint for the web, if you will. Next up, we use the file input to select a photo from the camera roll. So when I click Choose File here, it pops down my camera roll. But if that on my iPhone, it would just say select a photo from the camera roll. When we do that, we use the JavaScript file reader to do the actual reading of the file. And that's what gives us access to the file right inside the browser without having to send it off to a server and bring it on back. Next, what I did is I spit the image into the canvas. So basically what I did is I took the data from the file reader and I dumped that into a canvas element, part of HTML5. And then I manipulated the canvas pixels to look like a crappy filter. So with Canvas and HTML, you can take the pixels out of it. You can manipulate the red, green, and blue values, and then put it back in to have a filter. And that's exactly how almost all image manipulation programs work. And then optional, you can always kick off your canvas to a JPEG or a PNG to do that. So here's a demo. If you didn't get to try it out yourself, take a photo, select where, and there you go, crappy image of a sandwich. So look out, Facebook. Next up is Accelerometer. And this one's actually been around for a while. So if you remember back when the iPhone first came out, like I don't know how long ago it was, 5 or 6 years, one of the coolest games were the one where you could use this labyrinth game and you can move your phone around. So the accelerometer chip is a device that gives us info on how the user is holding and moving the device. It's helpful for determining what orientation someone is holding the phone, and it's also used in quite a few games. What people don't necessarily always know is that accessing your accelerometer is really, really easy within JavaScript, and it can be a lot of fun. So I'm running this in a web browser right now, and I'm running it on a MacBook Pro. And the MacBook Pro with an old hard disk drive also has an accelerometer in it. So if I were to click this, let's see if it's going to work. Let me pop it in a new tab, see if we can get it working. Oh, there we go. Okay, so I have this image hooked up to my accelerometer in my MacBook, and right now my MacBook is on a stand, so it's slanted. But if you could just visualize me sitting at my desk right now and picking up my MacBook and moving it around, or if you have the slides, do it yourself. Just click the image to start and move my MacBook back and forth. I'm getting the X and Y values of how I'm tilting it. So you can imagine that if you're moving your phone around, you'd be able to easily access all of the data of where your image is going. So accelerometer events, how do we do that? Well, to hook into accelerometer events, you simply bind to the following events. So we have device orientation, we have Moz orientation, which may just be orientation now, and we also have something called device motion. Now, all three of these events give you a little bit different data, so there is some normalization that you want to do. And I wrote a little plugin a couple of years ago called Jquery Accelerometer, which basically takes all of these, regardless of what device or browser you're on, and it'll normalize them into X, Y, and Z values. So if you want to check out how to do the normalization, I suggest you give that a read. It's good stuff. So that's accelerometer. Next up, we have compass. WebKit compass heading. We take a look at the previously mentioned device orientation event. So remember we said that we can bind to the following events right here. If we look on that event, there's something called WebKit compass heading. And what this does is it returns the number of degrees relative north. So if I was standing due north or straight north, whatever that word is, it would say 0 degrees north. So I'm standing exactly north. But if I flip entirely around, it would be 180 degrees. So you could basically just take your phone in your hand and hold it flat and circle around and be able to understand which way your user is facing. Along with that, there's also something called WebKit compass accuracy, which basically means sometimes the accuracy on your compass isn't as great. So it'll tell you, give or take, 20 degrees or something. I know here in Toronto, when we use the compass underneath the streetcar tracks, the compass isn't necessarily that great because it gets interference from the transit tracks. So the code for this looks like this. So we have window.addEventListener, and we're looking for device orientation event. If you want to support all the browsers, you'd add the other ones in there as well. And we have a callback function with the event here. And then this is where it all happens. So we look for the relative of north. So on the event, there's something called WebKit compass heading. And then we want to know give or take, which is the accuracy. So on the event, we also have WebKit compass accuracy. So, and then all I did was console log UR relative degrees of north, give or take. So maybe you are 20 degrees relative of north, give or take 3 degrees. Oh, great. Someone just posted the Jquery Accelerometer link in the chat. Thank you for doing that, Anna D. Example, so if you want to try it out right on your phone inside the browser, I know that iOS comes with this built in, but it's kind of cool that you can do it right inside the browser yourself. So the compass combined with with all the other things we talked about today could make for some really interesting data as to how you users are using your app. So next up is camera, and this is my favorite because I like to talk about WebRTC and get user media quite a bit. So WebRTC is a new technology that's on a block. It's actually been around for, I don't know, about 2 years now. And it's really gained some traction in the last couple months, and I've been seeing some really great demos out there. So if you're not familiar with it, I'm just going to tell you a little bit about it right now. Still under heavy development, and we're able to create something called a peer connection, which allows for a one-to-one channel between two peers. And actually, as of recently, you can also do many-to-many peer connection, which is great. What this means is that we can stream audio, video, and eventually data, and even now in Chrome, you can already do data over these connections without relying on a server in the middle. So basically, one browser will connect to another browser, and you can talk right between them without having a man in the middle. We would only need like a WebSocket or HTTP request or any of those things to create the initial handshake, and then the rest is all done through the browser. So the real benefit here is that hopefully soon we'll be seeing HTML5 chat roulette clone, because I really don't like using the Flash one. So that's really cool. And along with that, we get really new cool APIs that allow us to access the webcam and the microphone 100% in HTML and JavaScript. So previously on the web, you could only really do a webcam or audio from someone if you're using either a plugin like Java or you're using Flash in the browser, which both of them aren't really ideal. I'm actually doing the screencast right now. I'm talking about WebRTC, but the screencast is being powered by Java, and the chat and everything is being powered by Flash. So hopefully in a couple of years we'll be able to swap all that out for native HTML5. So no Flash required. you're able to stream your webcam right into an HTML5 video element. So you're all familiar with the video element. It's simply just video. And you can set the source of your video to be that of the stream that's coming right out of your webcam. So to use that, we use a method called getUserMedia. And this is where Canvas comes in. So once the video is streaming into an HTML5 video element, we can then dump those frames from the video into a Canvas element. So earlier I showed you how I use Canvas to put a crappy filter on the sandwich. But what if we were to do that over and over and over really quickly with a webcam and a Canvas element? So I already said this, HTML5 Canvas gives you pixel level detail of an image, and we can play with those pixels. So basically, every tiny little pixel gets access to the red, the green, the blue, and the alpha channel of that pixel, and you can change those to be whatever you want. So I've done some fun stuff on the desktop. Last year at FluentConf, I did a little video, and I also did a talk on it. Basically, when the stuff was still new, showing what you could do with it. I'll demo it real quickly here. So when I push start, you see it says wesboss.com wants to use your camera, and if you're using this in a browser right now, give it a shot. And I'm going to go ahead and click allow. And so there I am, everyone. Hopefully you can see me. I'm not sure how quick the video playback is. But basically what I have here is, if I bring it open my DevTools, you'll see here is a video element. Here is a little Canvas element that I'm doing the processing on because it's quicker to do it on a small camera. And then here I have the big canvas, which is for your benefit so you can see it nice and big, right? So I'm just going to close my DevTools. And on that, I can do the hipster. So you've seen this. This is the same effect that I put on the sandwich, right? But you can also do stuff like threshold. So basically picking out a certain level of pixels and changing them either to that blue color or to the white color. Next up I had the blur. So there's a couple stack blur algorithms out there which basically takes the pixels of an image and will blur them based on that. So just applying that algorithm to a canvas will give you kind of a cool blurred effect. Next up is green screen. So what you can also do, remember I talked about red, green, blue, but there's also that fourth one that I mentioned that's called alpha. And basically alpha is transparency. So the way a green screen works in television is that they put you on a solid color background, and then they search for that color and just remove it. They make it entirely transparent. So if I just move my red, green, and blue levels a little here, let's see if I can match my t-shirt. There we go. Beautiful. So right now I'm matching a specific range of dark colors, and whenever that dark color is found, it's just being picked out and totally transparent. And behind the canvas, I have just an image of a beach. So usually what I do is I take a piece of paper and put it behind my head, and it will replace those pixels with it. But it's more fun to do it with your t-shirt. And then, of course, there's one, I'm sure you guys have seen this before, where you can do face detection, which will basically find out where your face is and apply a set of goofy glasses on top of it, which is really fun. So that's on the desktop. But what about WebRTC on the mobile? What about getUserMedia on mobile devices? So WebRTC it's fairly new, and it's not many desktop or mobile browsers have implemented getUserMedia yet. However, lucky for us, Opera Mobile has come along. Over a year ago now, they've implemented it, and recently I was sent a BlackBerry from the folks at BlackBerry, so the Z10 or the Z10, depending on what country you're in, and it has fantastic support for getUserMedia, and the camera, you're able to do those camera things, stream it right into an element just as you were. So in order for me to help you understand where we could possibly use this, I need to tell you a story about my first world problem. So I live and I work. So I work from home, and I live in a really skinny and long house in Toronto. So it sort of looks like this, where it's really skinny and really deep. My office is all the way at the back of my house, but my mailbox is all the way at the front of my house. So hopefully you're starting to see the problem here. So when the mail lady comes, I have no idea when she's coming because I'm at the back of the house. The mailbox is at the front of the house. I don't want to have to get up and check the mail every few hours like a sucker. So here's my first world problem. I get so much awesome mail, but I don't want to get up and check for it every couple minutes. So, solution. I've created something called Wes's Law. It says any problem will go away if you throw enough technology at it. So I had 4 requirements here. The first is it must monitor my mailbox for the mail lady. The second, it must notify me when the mail lady comes. The third is it must be made up of existing technology I have laying around the house. So I don't want to have to go out and buy something to monitor the mail lady. That's kind of ridiculous. And then the third is it must be coded in web technologies because I'm a web developer. I don't know any Java. I don't know any C or anything else like that. I'm a web developer, and that's what I know, and I'm going to use web technologies for it. So step one, sorry, I'm watching the video, or I'm watching the chat at the same time, seeing hilarious people. Step one is pull the camera video feed into a web page, dump it into Canvas, and take a frame every 3 seconds. So again, do what we just did is we pulled the video feed, dump it into a Canvas, and take a frame every 3 seconds. Second step was to write some code to analyze and compare that frame to the previous one. So we're taking frames, and every 3 seconds, or however often you want to check, we're taking frame 1 and frame 2, and we're comparing them to each other. And the third step is if there is a difference between the 2 frames, we have motion detected. So basically you have an algorithm that takes frame 1 and frame 2, and we have a threshold of what the change would be. So maybe if there's a 50% change in the 2 snapshots, maybe trigger something that's saying that we have motion detected. So here's what I set up here. I just set it up on my local network, and this is the video element that I have right here, or sorry, a canvas element, and the green background is saying that there's no motion detected. When I jump right in front of it, you'll see that the background has turned red, and that's saying that motion has been detected because the camera is taking a snapshot every 3 seconds, and it's comparing the 2. And since I jumped in front of it from here to here, there was enough motion that it then says there has been motion detected. So already at step 3, we have motion detected / a security camera. It's honestly maybe 20, 30 lines of JavaScript, not a whole bunch. I have all the code up on GitHub, and you guys can go check it out. But that wasn't good enough for me. I still needed something for me to know. I still needed something to notify me, and I want it to be instant. So that's where enters Node.js and Socket.io. So the next talk, I believe, is about Node.js, so I won't go too much into it, but basically, if you're not familiar, it is server-side JavaScript. So we have 2 files running here. We have client.html, which is running on the device with the camera. So in my case, I would either be running it on, I would probably be running it on a BlackBerry now or on an Android device that has Opera Mobile running. And then we have another file called viewer.html, which is running on anything that wants to view the detected frames. So again, client running on the camera, viewer on anything that wants to view the detected frames. When motion is detected, we send that image over a WebSocket to everyone with viewer.html open. So if motion is detected on client, sends it over a WebSocket all the way over to viewer.html. At this time, you could also use Node.js to trigger emails, SMS, push notifications, anything you really wanted to. The final step is anyone on the other end, which is viewer.html, sees a stream of the triggered photos. So here it is. Here's me testing it. I jumped in front of it. So remember earlier you saw a picture of me jumping in front of the camera with the red and green background? Well, here's the other end of that, where I'm jumping in front of the camera and all the images are being sent over a WebSocket and piped into this page real time. So it was time to go live. As you can see from this photo here, this is just I think like a Nexus S or something like that, a 2 or 3 year old phone, and it runs it just fine. I plugged it in, I set it to never go to sleep, and you can see right here is my mailbox, and the mail lady or mailman would have to go up the steps in order to get to the mailbox. So I waited, and I waited, and I waited, and I waited, until suddenly, motion detected, mailman detected. So after running it for a couple hours, I had it running on my computer, and I had the browser window open on the side monitor. And a mailman walked in front of my mailman, and my screen started lighting up with images. So it triggered 4 times and sent over a WebSocket in seconds. So in the time that it took him to climb the stairs, and I don't know, he looked a little older, it may have taken him 2 or 3 seconds to climb up the stairs. But it just snapshot, 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 sent it over. I was able to see that and run to the front door and grab my package. So, first world problem solved. So let's do a quick review of all the technology that I used for my first world problem here. I used Opera Mobile, or now you can use a BlackBerry WebRTC with Get User Media for webcam access. Next up was HTML5 video for capturing the video. So we used Get User Media. We piped it into a video element, setting the source of it. We used HTML5 Canvas to collect the frames. And then we used the JavaScript Canvas API for getting the frame pixel data. So every 3 seconds or every 2 seconds, I was taking a frame and comparing it to the previous frame. I used the JavaScript algorithm for comparing the 2 frames. And then Node.js running Socket.io for a WebSocket server. And the Node.js side of this is probably 6 or 7 lines. Basically, it just says when you get something, continue sending it to the viewer. And then 2 HTML pages on either end running minimal custom JavaScript. So a quick device API overview. I'll wrap it up. I'm not sure if we have any time for questions, but we'll see. Device APIs in the browser let you access hardware directly, like many native apps do. While they aren't your common browser APIs, they can definitely come in handy, as well as open the door for some previously impossible use cases. Device API, device support in some areas is great, and others have a long road ahead of them. I haven't heard anything out of WebRTC for iPhone just yet, and I kind of doubt that Apple will do that considering they have FaceTime, but I'm really hoping that they do implement that in iOS 7. As browsers become faster and hardware gets beefier, we are able to push the limits of what we can do on a website. And case in point is I was running this on my 2-year-old Android phone, and then I ran it on the new BlackBerry Z10, and it ran a lot smoother. So really exciting feature. So that's it. Not sure if we have any time for questions, but I'd love to answer them if we do.
Okay, Wes, we'll take a question here from Java B. Where is the logic being processed for the video feed comparison that determines movement detected?
Oh, great question. So that's being done in the Canvas API. So let me see what we got here. With Canvas, you can run something every 2 seconds, and you can look at the pixels of that canvas element. So that's the nice thing about Canvas is we get it's a huge array, sometimes 1 million pixels within an image, and you can look at that data and see the RGB values of each of those pixels. So it's all being done in the browser and on a Canvas element, not on the video element.
Thank you. Question here from Matt Zoll. What is the support for the video/camera on mobile?
At the moment, it is Opera Mobile on Android and BlackBerry Z10, and I'm assuming the BlackBerry, the one that with the keyboard that comes out. It's best supported on the BlackBerry, but I'm also assuming that if you were to run one of the later Android phones, it would be really good as well.
Super. We'll take one more question here from Vikash. Does this input file work on iOS 5?
No, it doesn't. So that was one of the huge showstoppers for everyone for using file input because iOS 5 didn't allow you to do it. You couldn't access camera or files right from the browser, and there was no shim or fallback for that. So now that we have iOS 6 and it's pretty well adopted, we're able to start implementing it into our mobile apps.
Thank you again, Wes, and we'll turn the program back over to Peter and Simon.
Thanks, guys.
Yeah, thanks for that, Wes. I know that was really, people seem to really enjoy that because I've been reading Twitter the whole time, and so many people have been tweeting different quotes of yours on here, so I thought that was quite fun. As you've heard, sadly he can't make it to Fluent this year, but I saw him in action last year. He was really good. So thanks for keeping the dream alive on here today. Well, up next, the tempo's not slowing down, but we're moving on to the server side of things. So Pam Selly is with us to talk about rapid prototyping using Node and the Express framework. And as perhaps predominantly at the moment a Rubyist, I have a real love for something in Ruby that's called Sinatra, which is basically a lightweight web app DSL you can use to put together web app really, really simply and quickly. And Sinatra inspired Express, which is essentially a JavaScript/Node-based micro framework for quickly putting together web apps. And using this, you can quickly put together prototypes, get them up on the web, and get some testing going ASAP, live over the wire. So Pam's going to be talking about this at O'Reilly Fluent in May, but we've also convinced her to join us today and talk here as well. So without further ado, here is Pam.
Hi, everyone. Let me go ahead and get my slides queued up. So I'm going to talk today about prototyping a la Node with Express. And so generally what this is it's a little talk about prototyping and user testing, and I'll get into what those things are if that's new to you. But at the same time, it's a little talk about Express framework that we just talked about for a second, and how you can build quick websites leveraging Node in order to build quickly so that you can user test and prototype. So the idea is that between those two goals that you'll learn something. And so I'm going to talk about kind of the what and why of prototyping and what I mean when I talk about rapid prototyping for things on the web. I'll show you the prototype and the experiment that I designed and just how simple it is to get things up and running with Express and why I enjoyed using it for a prototyping methodology. And I'll also talk a little about user testing and how you can do it too and how it can be very cheap and very valuable to you. So what do I talk about when I talk about prototyping? So a prototype is an early sample or model. It's built for testing. So you saw in the past slide I had the MakerBot replicator. If you aren't familiar with 3D printers or adaptive printing, it's kind of a renaissance form of making physical prototypes lately. But as web developers, I talk about prototyping as making whatever level of your web app that you want to make so that you can test something. So the level that you make is determined by what you want to test. So prototypes are generally made quickly, so that way they remain cheap. and that you get a really good return on the work that you do. They're good for testing ideas, so built all around the testing. They're not necessarily pretty, but it does, that's partially put in there because I'll show you what I made and I am not a visual designer. And that's partially because if you make a rough prototype, you get people to think more of the big picture if that's what you want to test, and they don't get stuck on things like, oh, I don't like that this has gradients or that kind of thing. So by making it rougher, you can get them kind of unstuck and get really good feedback on what your prototype is aiming for and not let them get stuck on the design elements. And also importantly, prototypes are not permanent. They're made quickly and cheaply so that you can just throw them away, which leads to the great point that they are not the first iteration of a project. So if you're interested in user testing or you're trying to pitch this to your higher-ups or your engineering manager, they're really only cheap to make if you plan to make them quickly and learn the lesson that you need to learn, and you don't try and make your version 1.0. So that's a really important thing to remember about prototypes, and when you're going to pitch a user testing study that you're going to need to emphasize that. So here, it looks like my text ended up being a little small, but I have a list of some of the kind of the common and popular prototyping tools right now. Balsamiq is known for wireframing, but you can also use it for prototyping. You can make, if you ever use Balsamiq, it kind of has this cool sketch kind of style that they do, and you can actually create links so that your user could navigate around a PDF, and it would feel a little bit like, say, what an application might feel like. Just in mind, Prototyper exports to HTML, so you can put those on the web. And Mixture.io is kind of a newer one for rapid prototyping and static website generation that is pretty neat to check out. But what all of these have in common, and all the other ones generally, is that they're what you see is what you get. That's their, WYSIWYG. That's their value add. They say, hey, you don't need to learn to code, you can make your prototype. But the thing is that I feel like there's this frustration that programmers get when they try and use these things, or maybe this is why I became a programmer, is because when you start using these things, you just get frustrated about how they aren't customizable and you can't do everything you want to do. So say I wanted to make my test responsive. Using just in mind was a little bit harder to try and make a responsive design. If I wanted to start there from even the base test. And so that's why I say forget that. We'll do it on JavaScript. So I'm going to go show you what I made and why it's good enough for testing, even though I already warned you that it's not beautiful, and kind of go over how easy it is to get up and running in Express. And of course, in a classic demo manner, I managed to break the current version on the internet if you go to it right now. So this is Neighboards, which is my beautiful prototype for testing between these two modes. So I made two different versions. So I tested this version first, and then I came back later and started testing with the other version to see how a different kind of UI. And you'll notice that there's just one big UI difference is Pinterest style versus list style. And so that's what I decided to test. This was just kind of an experiment in user testing. And so that's why it's not super built out. But if you want to go to Neighboards B in your browser, that one still works. I didn't break that one before the talk. And so if you click on things, you get a little modal. And so right there you can see some of the things I learned from testing was when I got this in front of people, I didn't have the modal overlay you commonly see. So it closes. It has some basic, it fills in that I can log in. I'm logged in. And so it kind of gives the feel of a web app, except it's really absolutely not. There's absolutely no database. There is no infrastructure behind this. It's total nonsense. The login is just a global variable. It really was really easy. And the point is that it was super duper easy, and that you can do it too, because the whole point is to get feedback and to learn something from it. So now let's look at how we can get started in Express. So since this is actually, that's a prototype. There we go. Okay. So the first thing when we get started with Express, start with a package.json file. And this is all it's literally only 3 files, very easy to do. And so I named this Fluent idea. I have our dependencies defined as this is the current version of Express that I have. The engines that are needed are Node and NPM, because I put this on Heroku, which you can tell because I have a proc file in there. So a proc file is the file that you use to tell Heroku about how it will run your application. And so that's all you need for the package. The proc file, which is what we use Heroku to run the application, we say Heroku, do a web process, and just use this command node web.js to run the application. Fabulous. So what's web.js? Well, web.js is 10 lines long for our demo because this doesn't use any templates or anything yet. This is literally just how to run an application using Express. And so we require the Express framework. We initialize an application using Express, and then we define a quick route. So for me, when I was getting started with Express, it helped to think of it. I know that we said in my introduction, we said that it's similar to Sinatra. So if you're familiar with that, it's kind of like that. So you can add as much or as little as you want. For me, all I really wanted was just simple routing, and so that's what I used. And so in this very simple example, we say if you get the root, then the request and the response, send to, for the response, hello new prototype. And this line on 8 is what you need if you want it to work on Heroku, because it'll have this constant. And then you say app.listen port. So it's very, very easy. So let's see what happens. And it didn't work. Okay. So dangers of live demos. But I hope that you did get the idea that this did work a little while ago. I've had a lot of problems getting all this software up today for the webcast anyway. But so let's say that it did. You would see just a little something. It would just say hello new prototype in the browser. And if you want to see how I built neighborhoods, it's over there over on GitHub. You'll note that it's really not amazing. That's the whole point for me giving this talk, is that you can do this and it's very easy for you to do, very accessible. And one of the great things about Express as a framework is I did mention that, so the mini demo that we tried to do didn't use any templating, but I believe Express supports 14 different templating languages. So I use Jade because I like Jade in my little prototype. But you could use whatever you like, basically, because Express is so flexible and supports all those kinds of things. So I'll go ahead and get back to the slides. If you don't want to run the risk of having your demo not work on a webcast, you can cheat to win using Express. And so you can, NPM Node Package Manager, you can install Express globally, and that gives you access to an Express command line tool, which is analogous to, say, Rails new. It builds a whole bunch of scaffolding for you so that you can just run with it, builds public directories and all that kind of stuff. That was something I found out about after I did all the work to build my prototype, but I would recommend it for rapid prototyping. So now on to user testing. So just in case you want to know, user testing is what I use to refer to when you interface with people, also known as users, to find out more about your prototype or your application or what have you. So I am not a usability expert. I am not a user testing expert, but that's part of the point of doing this user test is that I can get good feedback on my application without being that kind of expert. There are plenty of people who are very good at it and know a lot more than I do, and if you want to know more past this talk, I would suggest you check out some of the things that they're up to. And I have a book recommendation at the end. So I'm going to cover how we can test early, look for heuristics violations, and I'll talk about what heuristics are, looking for emotion, and documenting. So, and all these are pictures from the actual user tests that I did. So this is my friend Eric. So testing early. So this is one of the key things I like to emphasize when I talk to people about doing user tests is that you want to do user test and get feedback before you spend lots of time, money, and resources. So by testing early, you can reduce, say, frustration when a feature is scrapped. You can also prioritize features and say, wow, people really can't use our application if we don't build this, or, oh, no one seemed to notice that, so maybe we can move that down the list, and we can work on the things that are most important. And also great for idea validation. So that's what this one was used for, was here is this neighborhood's application that would be like, say, like a neighborhood bulletin board. Would this actually be useful? Would this make sense? Could you actually use it? Would you go read it? Would you engage with it in multiple ways? So that kind of idea. So why would you do it, test early? So looking for heuristics violations. And so this link is to the Nielsen Group 10 usability heuristics. And a heuristic is kind of an experience-based technique such as, if you have heard, there's lots of things that people will say, and that's kind of what a heuristic is. So if you don't know how to solve a problem, try working backward. That's an example of a heuristic. It's an experience-based technique. So one of my favorite examples from the Nielsen list, which you can look at yourself when you have the time, is clear errors. That if something goes wrong or doesn't work, that your user really wants to know why. That's one of my favorite ones that also I see violated a fair amount on the web. You also want to look for emotion. So this is my now friend, Mark, who volunteered for my user test, and he got really, really mad. And it was really, really valuable for the user test because anger is very informative. So you immediately know that something is wrong. It's a very clear emotion to understand, and usually because they're angry, they'll articulate the problem really well. They'll say, I'm angry because X. And that's part of the thing that you need to do when you're user testing, when you're running the test, is that you need to get your user to talk. So if they just kind of poke around and you kind of watch them, as not as useful as if you say, hey, can you talk through what you're doing? Let me know, why does that not make sense to you? Tell me more about that. Tell me more. Tell me more. And that's how you get the good information out of them. And of course, the user test only matters if you actually take something from it. So document. So I took some pictures that would remind me of, say, like that Mark got angry when he was at the preferences screen. So take pictures, take limited notes. You just don't want to make your users feel like lab rats. So do take some notes, but don't make them feel uncomfortable. You want them to feel as natural as they possibly can. And part of that is that you take time after the user test to take all your notes down, just kind of do a brain dump, and then also check what you observed against well-known usability heuristics and see if your application perhaps violates some of those heuristics. And then importantly, you iterate. You say, okay, well, I didn't have a clear error notice there. Let's see what happens when I have an error notice. And then maybe next round of user testing, you might test the same area with a couple changes, or you might actually do, say, a kind of A/B test where you would have one group seeing one change and one group seeing another. And that's how you can get good feedback. Okay, and so in summary, hopefully we covered how we can prototype and why. We learned a little bit about Express and how easy it is to get things up on the web. and a bit about the how of user testing. So just some final notes. Express is really great, but if you are already familiar with it and you want to learn something new, I would suggest checking out happy.js, which is a new on-the-scene Express alternative that's really good. And then the classic book in usability and user testing is Don't Make Me Think. So if you haven't read that, it's a really great introduction to the how and why of user testing. So thank you very much.
Thank you very much, Pam. We do have a couple questions that have come in here, so we'll give them to you just in the order they came in. A question from Siddhant. Is Express then server-side or client-side, and can it work with Bootstrap?
I would say that I would classify Express as server-side because it's leveraging Node, which is at its most simplest form a way of doing server-side JavaScript. So Express is a way kind of like replaces a backend, say, instead of doing Rails or Sinatra or Flask. And you can use it with Bootstrap because Bootstrap is just UI components and also some JavaScript. But I actually use, say, Jquery in the Neighbors prototype, so you can definitely use Bootstrap.
Great, thanks. And a question here from Fada. Why was Heroku necessary for prototyping, looks like Neighbors app? What would have she done if she didn't want to run it in Heroku, but just in HTML5 or JS?
Good question. So Heroku was not necessary. So part of this was that Heroku is really nice because it's very easy to ship applications, but there's absolutely no reason you couldn't ship an Express application on any kind of application service, platform as a service, or servers that would support server-side JavaScript. So anywhere you can support Node, you could do a Express application. So Heroku is not required. It was just part of the example, which I would have gotten to if I didn't have to bail on the demo, that it's really easy to ship to Heroku. I think I made a demo video where it only took from zero, it took 3 minutes to do the entire thing.
Great, thank you very much, and I'll turn the program over to Simon and Peter.
Thank you very much, Pam. I need to spend more time in Express and some more time actually testing applications with users. The piece about angry users who actually talk is really true. So our next speakers, Brad Green and Shyam Seshadri, will be talking about Angularjs. We'll be covering a lot of different frameworks at Fluent, but Angular has really grown very quickly. It feels a bit different from the rest. Brad is an engineering manager at Google. Shyam is a former Google engineer now working at Fundu Solutions. And I know them in a different way because I've been the editor on their O'Reilly book on AngularJS, and that should be out in a few weeks. So over to you, Brad and Shyam.
Hey, thanks. We're very excited to be here. So yes, I'm an engineering manager here at Google, and I manage the AngularJS project. And Shyam used to work with me, and he was the first engineer to build an AngularJS application, and he collaborated with Mishko and the rest of the team to make Angular what it was in its early incarnation. So we're going to walk through what we feel are some of the principles behind AngularJS, the things, sort of the end effects that we've been trying to reach, rather than just kind of covering the APIs and talking about it. So we talk about Angular as what we call a framework for client-side web apps, rather than calling it a library, and I'll make the distinction a little bit. So by the way, all the other speakers I think were fantastic, and they talk about things that work very well with Angular. So of course we use JavaScript as a JavaScript-based framework, although people do write in CoffeeScript and TypeScript and ClojureScript and other variants. And Node.js makes a wonderful backend for Angular. The thing that Angular does is it provides a way to write your templates and a way to wire your applications together. The way we've tried to design Angular is maybe a little different than other frameworks you've experienced, in that we've been trying to build something that felt like just additional infrastructure that's provided by the browser. And when I say that, I mean that you should just feel like the browser is doing extra stuff for you. What this really means is we haven't provided any classes that you must inherit from, and there are some functions that you call, but a lot of things just get handed to you. And we're going to cover how this all works and how you can use this to build what we think are very applications that are easy to create, maintain, and test. So the principles we're going to go over are first, we thought a lot about the developer experience. We created Angular kind of as a research project to begin with, but as something that would address our own developer pain, to make it just easier to think about how we laid out our application and how an application can grow to very large with a lot of developers over time, and how this could all remain very fast and very clear for all the developers working on it. The second thing that we're going to go over is the application structure itself, and how this first principle leads into the way we provide structure that lets you write your user interface very much in a declarative style, where I don't actually write code for it, but I just specify what I want in a template rather than exactly how to do it. And we let Angular take care of a lot of the UI bits. But then for the business logic and the things that are unique to your application, we give you specific places in an Angular application to write that code. So it's very clear where to put what. And then last, we, from the beginning, thought about what does it mean to ship an application? And we know that shipping means testing. And so we wanted to make testing, developer-style testing, that is, where you write unit tests and end-to-end tests. We wanted to make that very easy. And we do that from both a tooling perspective, but also from how the application is structured. We'll talk about this. So Sham is going to take you through some of these first parts, and then I'm going to come back and describe a few other parts of Angular and where we're going as a platform.
So let's start with the first principle. So as a client-side developer, we really end up fighting with the browser to get it to do what we want when we want. With Angularjs, we aim to create an environment where the browser actually works with the developer instead of fighting him tooth and nail. When we say Angularjs puts the developer first, we mean that it tries to make our life as simple as possible by relieving him of some of the common headaches and cruft that otherwise take time and effort. For example, here are two things off the top of my head that AngularJS does. The first is what we call custom components or directives. The HTML component library is quite limited to input fields and buttons. But I really want to be able to say, in my HTML, here's a date picker, here's a carousel. AngularJS allows you to teach the browser how to understand these new components that you create. And the second is data binding. A significant portion of the code we write today deals with funneling data throughout our application. Get the data from the server, push the data from the JS to the view, update the view when the data changes, and then finally grab that data to send it back to the server. AngularJS does this all for free with data binding, where you don't even have to write this funneling code. So let's take an example of how data binding looks in an AngularJS world. So here we have a complete AngularJS application. So I'm not going to do screen share, but if you just join me in imagining, there's basically a single text box in this application and a paragraph right below it. And as you type into that input field, the paragraph below it updates. So you get, as you type update, so you type in Sham, you'll see hi Sham in the field below. So this is a complete AngularJS application, a simple one, but a complete one nonetheless. It takes the user's name from the text box and displays it in that paragraph down below it. The template is pure HTML and just includes the AngularJS source code. The ng app attribute at the top is what defines this HTML page as an AngularJS application. There are really 3 points of interest in this entire HTML, and we'll cover them. The ng model that we have here says that there is a user object, which is a JavaScript object, and it has a name field on it. And we want to bind that name field with this text box. So basically, this user.name, which is a JavaScript object, becomes the backing model for this input field. We then have this paragraph with the user.name in double curly. The user.name is again referred to here, and this is the same user.name that we referred to in the input field right above it, where we've used it as the backing model. Here, the double curly denotes that the value of user.name is to be replaced in this place. And that is to happen whenever user.name changes. You get the basic as you type update. Also note that is in this entire thing, we haven't written a single line of JavaScript code. We haven't written a single listener. We haven't done any DOM manipulation or ID lookups or class name lookups. This is pure HTML right here. The next principle is that of app structure. One of the essential necessities for a project is to have maintainable and readable code. One of the ways we achieve that in AngularJS is what we call separation of concerns. This goes back to the single responsibility principle, which states that each piece of code is responsible for one and only one thing. For example, we have classes and functions which are responsible purely for the business logic and have no clue, do not know about the UI or the DOM or how the UI is updated. They never reach into the DOM to set up the views. AngularJS achieves this by having very strict opinions on how to organize and structure your code. You can divide a basic AngularJS application into three parts. The controller is then responsible for then modifying the state of the model and through that, the state of the application. Now, bringing this concept to the browser world, we have pure JS objects for the data or the model, the HTML or the DOM for the UI and the view, and JS classes, functions, all of which are defined in pure JS files, which become the controller. We're still having trouble with the presentation.
Okay, we're on principle number 3 now?
No, the MVC slide. 57.
Here we go.
Okay. So let us take a look at another full AngularJS application. We include our Angular dependency as well as the controller through the script sources. And then we have a new attribute in gController on the body. That refers to the user controller that is defined in the controllers.js at the bottom of the file as a separate file. And notice that there is no constructor call anywhere. We don't have to tell Angular how to create the user controller or what to pass for its argument. That is all handled by the dependency injection framework that we'll cover in a bit. Now, in the controller.js, we define our user controller, and in that, the user controller gets injected or passed in an argument called a scope. We define the user object on the scope with the name Larry. The scope is an AngularJS concept that we use to ferry data and business logic between a view, which is the HTML, and the controller. Notice that in the controller.js, we never have to reach out into the DOM, manipulate the DOM, find something by ID, and put the value. That is all handled by the data binding. The business logic code is clean and independent of the view. The view also refers to a by function with the ng-click on the button. This, again, comes from the user controller, which we exposed on the scope. And because the user controller doesn't know or care about the DOM, we can test the business logic easily as they are pure JS classes and functions. And because of this separation, we can relay out the entire UI without touching a single line of JavaScript. Next slide. Principle 3. Now, most people would agree that testing is important, that a well-tested code base is easier to work with and maintain than an untested one. But still, very few people do it. And that's because testing, historically, especially in the browser environment, has not been easy. You always have to fight an uphill battle against the system to write your test because of the existence of global state, because of the asynchronous nature, and so on and so forth. But not so with Angularjs. Angular was designed with a test-driven approach. And so each and every facet of Angularjs, and by extension, Angularjs applications, are easy to unit test. And a major reason for this is the dependency injection system prevalent throughout the framework. Next slide. So why is there this huge emphasis on dependency injection? There are 4 major benefits that I'll talk about here. With dependency injection, you always ask for your dependencies instead of initializing them yourself when you need it. This gives you the flexibility of passing a controller or a service a mock or a reconfigured dependency in your test. If you have a controller which makes server calls, pass in a mock which does it in memory in the test. Secondly, because components never instantiate their dependencies, they also don't know what the dependencies depend on. This means that I can easily swap out a dependency, say that used to provide mock data when I prototype my application, with one that talks to a real server and fetches live data without changing the components that depend on it. Third is the fact that since everything is dependency injected, we really don't need a main method. The main method is typically where you hook up everything together and usually is a giant untestable mess. The cascading initialization in Angularjs takes care of that for you. Finally, you can rely on the dependency injection system to hold state and communicate everything else under the sun. This means that you can do away with that messy, flaky global state that required cleanup in case you were testing. Things just work in Angularjs. So let's take a look at how this dependency injection system is implemented in Angular. Next slide. So let's take a look at our user controller again, which we now want to teach to say hi to the user instead of alerting them. So the user controller asks for a voice send service in its constructor. Notice that it doesn't specify what type of voice synth it wants or how it should be instantiated. It's completely independent of the implementation. We then use that voice synth service and call say on it. The voice synth service has a method say on it that internally uses a web audio dependency to actually speak out the words. That gets passed in as a dependency as well. All of this is hooked up at the end of the code by telling Angular what to provide when someone asks for a user controller and what to provide when someone asks for a voice synth service. Notice that we tell Angular to provide the voice synth service defined above when it is asked for voice synth with a lower v. Next slide. But really, in our tests, we really don't want to grapple with web audio dependency, right? We'd rather pass in our mock voice synth service, which has the same API, has the same method state, but instead of reaching out to a web audio server somewhere to speak out the thing, we just store it in an array and then assert on the contents of that. So we then define a mock module which overrides the voice synth service to now provide it with our newly defined voice synth mock. It's important here that the name that we use, voicesynth with a lower V, matches the name we used to define our service initially. With that, in our unit test, or any other controller that asks for voicesynth will get the mock one. And we can also ask for the same service to then assert on the contents of the array. As simple as that. Next slide. So more testing support. AngularJS is built with testing in mind, and its APIs reflect that. Whether it's the ability to configure services with parameters, or the whole dependency injection nature that allows you to swap out services with mocks as you need it. It makes testing easy. But it's not just that the APIs are designed with testing in mind. AngularJS also provides inbuilt mocks for common problematic browser APIs that usually deal with XHRs or global state like location. So if you want to test a controller which fetches data from the server, you have to use the mock HTTP backend service, set your expectations and on the requests and responses. And your tests will now execute in milliseconds stably, and you can even control when the responses come back and how soon they come back. And driving this entire thing, this entire focus on testing, is our spectacular JS test runner, which is now called Karma. This is a super fast test runner that we also use for running our AngularJS unit tests. And we run about 1,500 odd unit tests in less than a few seconds. That's how blazing fast it is, and that's how fast it can make your own testing experience. And with that, over to you, Brad. Take it through.
Okay, great. Thanks, Shyam. So let's just recap some of these principles that we covered. At the beginning, we talked about developer first. There's a bunch more to the story that we'd love to share with you, and we'll show you some links at the end where you can go find out more. Shyam talked about app structure and where you can put specific parts of your code. I'll talk a little bit more about that in some upcoming slides. And then finally, something that's very near and dear to our heart is having testability baked in. Before I continue, I think we should mention, like, the way we actually think about AngularJS internally is that it is a framework that you can use out of the box, but it's also the way we designed Angular is we actually built a framework for building it. And what I mean by this is we call it a meta framework. We built something that can work for you, but the core components of this are a dependency injection container, a template compiler that lets us extend HTML, and this model mutation observation function that lets us do data binding. So we've built one expression of the way we think applications can be structured with Angular, and most people will use this out of the box. But we've also shipped you all of the components you need. So if you wanted to kind of re-envision the way the world works in a JavaScript application, you could use these low-level components as well. Now, the one I'm going to focus on is this template compiler, because most people actually do extend this themselves. So its job is to take a look at the template. And you notice that we added some things in HTML, attributes and elements that aren't part of the HTML spec. And the compiler goes through and it finds all these elements. And then it transforms them into the DOM view, into the live running DOM that your users will see. Let's just take a look at some of these elements. So Shyam went through a couple different examples of things like the ng controller attribute and the ng model. So these are all just extensions that explain how your application is wired together. Another example is ng repeat, which will stamp out a bunch of copies of a piece of DOM for every item in some model object. So for example, here we say that we want to repeat a list element for every item in the items array, and where we'll set a style to the color, and we'll set some text in the list to item.name. We could also create our own components for things like, well, I want to have a color picker. You can define these yourselves. And let's just take a look at some other examples of things you could do in Angular. And these extensions to HTML are what we call directives. And some examples that you could write and actually exist if you go to some of the Angular UI libraries like Angular UI, like the Kendo UI with the Angular bindings, and like the Wijmo UI framework. So you might have something like a star rating that you could express in your template simply as rating, where you pass in max 5, and you might bind its model to stars.average. You could do something like a set of tabs, where instead of putting a bunch of divs and spans in your application, you could actually express it as something that's more akin to what you're trying to do. So actually saying what you mean, where I've got a group of tabs, and each tab in tabs will specify its title and some information that goes in the actual content below. Now this is an interesting one because tabs the tab set will do all the switching between tabs for me, and it'll have to highlight which one is active and show the titles. So the individual tabs contained in the tabs set have to communicate with its enclosing component. And so we have this concept of having nested components that can communicate with each other. And then finally, I want to make a point that these components are composable. And you can define them either as elements or as attributes. And so, for example, we have one called tooltip, which I can add to any DOM element. Here we added one to a span. But I could have added it to a tab as well, or I could have added it to the rating. So that I can compose a bunch of individual pieces of functionality or structure that work together. Now, just as an example, to show you how we write these things, a while back I was writing an application where I needed to focus on a link. I wanted, as soon as the page loaded, I wanted the user's mouse focus to be over, or keyboard focus to be over a link. Now, I remembered that the HTML5 spec had this cool new autofocus feature, so I thought I would use that. Now, it turns out autofocus, I think, only works on input elements, so that wasn't going to work for me. So I just defined a directive of my own where I said when this is on an element, I'll just want to get that element and call its focus method. So if you see in directives.js, I'll specify this very brief specification for how it works. And then down below, if I want to use it, I can just put it on any input, link, div, anything in my application, and it will focus on that first. So we've just gone over, I think, the scratching the surface of Angular. There's a ton more in Angular that we think rounds out the application nicely. Filters, promises. We've just released a suite of animation directives that allow you to declaratively attach animation for both CSS and JavaScript-driven animations. We do localization, form validation. We've stolen a lot of good ideas from other environments out there like Ruby on Rails, where we have things like views and routes. We make server communications easier, and there's a ton more in the sort of unit and scenario test infrastructure that we provide. I wanted to wrap up with just a couple words on where we're going. While we've been doing things that certainly push browsers to the limits and maybe look like magic, if you remember at the beginning, I said we wanted to do something in a way that felt like it was part of the browser. We're actually trying to make good on that by driving some of these concepts in Angular into specifications that we're now starting to see in the web browsers. And one, there's a TC39 spec called object.observe, and this is a low-level primitive that we can use to do data binding. And what this will mean is that our data binding will get faster and will just work more seamlessly in browsers that have it. Similarly, for extending HTML's syntax, there's a spec called web components. And both of these have been well accepted and are starting to see implementations in today's browsers. And what we're doing is working with these standards folks to make sure that this can work for Angular, and we'll just use them under the covers. You as a developer won't have to do anything special, but in browsers where these standards exist, your applications will run better. There's another spec that's starting to emerge called model-driven views, which is, you can think of it as the way that the model observation and the web components interact. We're very excited about this. This is new for us, and again, we're working with these folks closely to make it one of the underlying pieces of Angular. So in a broad sense, where we're going is Angular, we intend to provide more of the high-level application infrastructure and push some of our core implementation down into the browser itself. I hope that was useful, guys. Thanks for listening, and we'd love to answer any questions.
Thank you so much, Brad and Sham. Really, really great presentation there. We do have lots of questions that have come in, so we only have time for a few folks, and we'll just take them in the order they came in. A question from Vladislav. He'd like to know, what is the Angularjs relationship with Google?
That's a good question. So Angularjs actually started as an open source project by one of our members at Google here, Mishko Hebry. And Mishko had this audacious claim that he could rewrite an application we had been working on for 6 months in 2 weeks using this external project. He did it in 3 weeks. So it was a total failure. But we thought this was interesting. We assigned some folks to actually work on this as a full-time project, and what we see today is Angular. We contribute a lot of source from here at Google, but there are folks all over the world who contribute to it.
Thank you. Next question here from Kirk. Are all the controllers and models global in Angular?
So our intent is that none of the controllers and models are global. We provide scoping mechanisms through the dependency injection framework so that nothing appears in global state. We believe this is a very hard thing to make maintainable, and it makes testability very, very difficult. So no, the intent is that none of these things end up in the global state.
Okay, next question here from Eugene. How about REST API data loader and rendering data from it? How does it work?
So there are facilities in Angular that make it very easy to work with RESTful data APIs. For working with the basic HTTP protocols, there's a $HTTP service. But for doing RESTful specific things, there's another library that goes with Angular called Resources. And Resources allow you to sort of build an API that works with your particular flavor of REST for your server.
Great, thanks very much. And I'm going to turn the program over to Peter and Simon for their closing comments.
Great. Thank you again, Brad and Sham. The additional infrastructure provided by the browser approach seems like a really nice way to do things. I keep hoping that browsers will learn from frameworks, and this seems like a good way to do it. We'll be looking at Angular, Ember, Backbone, jQuery, and many more frameworks at the main Fluent conference, which will be from May 28th to 30th in San Francisco. If you've enjoyed this preview, please take a look at fluentconf.com to learn more about the main show. We'll be covering much, much more territory. Thanks again to all our speakers, and we hope to see you there.
Yeah, I've not got much to add other than it would be great to see you there. But also, if you had a favourite talk here or something like that, it'd be great to see you tweeting because I've been reading all the Fluent Conf tweets. I've been enjoying that, so look forward to interacting with you on there. So that's it from me as well. Thank you for coming along.
Thank you.